Hello everyone, welcome back. This video is about Arduino interrupts. So what is interrupt? Interrupt is basically a mechanism that allows microcontroller to respond immediately to a specific event or condition without constantly checking for it in the main program loop, that is a void loop. Interrupts are used for event-driven handling of external events like button presses, sensor reading, or timer overflows. When an interrupt occurs or when the specified event occurs, it triggers the associated interrupt service routine. So this is basically extra function in the program. It's bunch of code where we define what should happen when an interrupt triggers. Arduino support different types of interrupts like external interrupts, pin change interrupt, timer interrupts, and ISR, which is interrupt service routine, and it is basically a separate function that you define in your Arduino sketch. So whenever an interrupt is triggered, the program will jump into this ISR. It contains the code that you want to execute when the interrupt is triggered. To enable or disable interrupt, we have functions from Arduino library, that is no interrupts and interrupts. There are in total 4 interrupt functions for Arduino interrupts. 2 is external interrupts like attach interrupt, detach interrupts. If you are connecting any switch or any external signal to your Arduino, you need to do the configuration using this attach interrupt for enabling the interrupt and detach interrupt to disable the interrupt. And in the main function or in the main program, once you attach your interrupts in the configuration, in the main program, if you want to enable interrupt, this function is used for that, and for disabling the interrupt, this function is used. If you want to learn more on these functions and what are the syntaxes, you can go to Arduino references for interrupt. Let's have a look. So this is the page from arduino.cc reference/n. From here, if you go down, you will find 2 sections like external interrupts with 2 functions, attach interrupt and detach interrupt. And from interrupts, you have interrupts, no interrupts. So these are the functions we can use for working with interrupts. Let's take a look at the attach interrupt. Now, if you are using external interrupt and digital pins for interrupt, then you need to check out this table first. For Arduino Uno, Nano, Mini and other 328 base chip, the digital pins usable for interrupts are 2 and 3. So in the Arduino Uno, you have digital pins from 0 to 13. Among them, you can use 2 and 3 for digital interrupts. Also, there's other board here, you can check them out. Like many of us, we use Mega 2560 or Mega board for larger projects. They have several pins for digital interrupts like 2, 3, 80, 19, 20, 21. You can check out this table when you are working with interrupts. Let us talk about the steps of using external interrupt. First step is we need to configure the hardware first and choose the external interrupt pin on our Arduino board. Like in the previous table we have seen, we can use 2 and 3 for Arduino Uno. The available external interrupt pins vary depending on the specific Arduino model, as shown in the table. Common in choices include pin 2 and 3 on many Arduino boards. The second step is connect your sensor or signal source. In this case, we are using a digital switch, that is push switch, for our interrupt triggering. So hence we will connect the sensor or signal source to the chosen external interrupt pin. In our case, we are using 2, and we need to ensure the signal source and the Arduino share a common ground for the reference, and that's also has been done here as we are taking ground in the switch itself. Third step, to declare global variables. From here, the programming part starts. Now, the term global variables, it might be new to many learners. So let me clear the fact first. What is global variable and local variable? There are 2 types of variable with respect to the scope and execution. The first one is global variable. It is accessible from anywhere in the program. Its lifetime exists throughout the entire program execution, and accessibility can be accessed from any part of the program. Whereas local variable is, it is limited to a specific function while it is defined. Lifetime, it exists only while the function is executing. And accessibility, only accessible within the function where it is declared. Now, here's the dummy program on the right hand side. You can see, as we use in Arduino, this is the void setup for configuration and void loop, our main program, we put it here. Now, let's say we have used another function, that is void sum function. It's just a dummy name. Within the function, we have initialized another variable, that is int local var, and we are assigning a value of 5 to this variable. So this local var, this variable is only accessible within this scope, within this bracket, and within this scope of sum function. But we cannot access the local var from other functions like void loop or void setup. So this is the properties of local variable. Whereas the global variable, int global var is equal to 10. This is one global variable example. This variable has been defined and initialized outside any function. We can access this global variable from void setup or from void loop or from this sum function also. This is the difference between global variable and local variable. In a brief, local variable is only executable, only accessible, and only exist within a specific function. Out of that function, it is not known or it is not usable. Whereas global variable, it can be used throughout the whole program. It can be accessed throughout the whole program from any function, from any place. So that's the difference between global variable and local variable. When we are using global interrupt, we need to define some variables like global variable so that we can access them from interrupt service routine or other functions. In step 3, that is why we are using global variable. This is to define variables to hold the pin number for external interrupt and any other variable you need in your skate. Like we can use constant in to hold the pin number. We are using a variable interrupt pin, and volatile int interrupt counter. For using a counter, we are using this sort of variable, and these are defined and initialized outside the scope of any function at the top of the program, and it will be used for global variable. Now here comes the step 4. In step 4, first we need to configure the external interrupt pin as an input. So using pin mode, we will define the interrupt pin as input pull up. Remember, input pull up, we need to use it here if you are using internal pull up configuration for the switch. Next, we need to enable the specific external interrupt using attach interrupt. So attach interrupt, this syntax is attach interrupt. After writing that, digital pin to interrupt, you need to define the pin number here. Then ISR, you need to put your interrupt service routine function name here. Then comes the mode. For attach interrupt, we have 5 mode here. The first one is low, which means whenever the pin is low, it will interrupt the trigger. The second one is change. Whenever the pin changes value. Rising, it means whenever the pin goes from low to high. And falling, whenever it goes to low from high. So any of this is available for our Arduino Uno. But if you are using Duo, Zero or Maker Series board, you can also use high as mode. Now comes the 5th step, that is defining interrupt service routine, in short ISR. We need to create a function to be executed when the external interrupt is triggered, and this function is called interrupt service routine. What we need to do within this function, inside the ISR or interrupt service routine, we need to update some variables or perform some specific actions, or we can also set flags based on the interrupt event. Like here at the right hand side example, we have used a void handle interrupt. This is the name of the interrupt service routine. Within the function, we are using a counter like interrupt counter plus plus. It is incrementing the value of the counter. And we are also using a delay, as we are using switch for external interrupt. With the switch, the debounce effect might come at the external interrupt. So to handle that, we are using a delay here. Now let's put together all the steps we have talked about and see if we can relate them together. Let's perform the step 1 and step 2 that is related to the hardware setup. We'll first bring in a push button from here and we will tick up this bounce for now. Okay, so we'll be using internal pull-up resistance for using this push button as a switch. So that is why we'll connect this terminal, one terminal, to pin 2. Our external interrupt pin 2, we can also use 3 here. Both of them work. And from the above 2 pin, any of the pin will connect it to ground. Let's make it black here. Okay, so this switch, it will work as the source of our interrupt. The step 1 and step 2 is done here. Let's do the step 3. The step 3 was declaring global variables. So let's do that step here. We'll take one variable for defining the pin for our interrupt. So that's why we'll take constant int interrupt pin, and we are using 2. So that's why we will put 2 here. We'll define another variable here for doing the count. How many times we are pressing the switch, we will count that. So for that reason, we will use another variable. We can use volatile type integer. We are using the name as counter and initializing with the value of 0. So this will cover the step 3. Now comes the step 4. In step 4, we need to do 2 jobs. The first one is defining pin mode. So let's do pin mode. And we will put the interrupt pin as input pull-up. And the second task is to define attach interrupt for external interrupt pin. Let's do that. Attach interrupt. From here, the first parameter it takes is digital pin to interrupt. Within the bracket, we'll put the interrupt pin name, that is interrupt pin for our case. The second parameter it takes is the ISR function name. So let's put a function here, void, and we will use the function counter function. This is a arbitrary name. You can make any name here. So this will go here. That is the counter function name here. Then you can use any of the mode of interrupt. I am using the rising. So now comes the step 5, defining the ISR function. In the ISR function, we want to count how many times the switch has been pressed. So it was initialized at 0. At the first time the interrupt was triggered, it will come down here and it will increment the value of counter with 1. We can do that using counter plus plus. So counter plus plus is basically counter is equal to counter plus 1. So this is the increment operator here we are using, and we want to use delay for handling debouncing effect. So let's put 200 here. This will count how many times we have pressed the switch. If you want to print that value at a serial screen, we can do that also. Let's initialize the serial print with 9600 baud rate, and within the void loop, serial dot print switch pressed. This is the message we are putting here. Then serial dot print how many times switch has been pressed, that is the counter. And for next line, we are using a skip sequence /n for new line. So this will be all for the program. Now let's see if our program works with our setup. So let's run the simulation. Switch pressed 0 time. Let's press it once. It is pressed once, then 2, 3, 4, 5, and it's going smoothly. So that will be all for this video. See you in the next video. Thank you.